we can use set builder notation for more than just a number line. We can graph individual or sets of points with this set builder notation. In this particular case, we have the point xy, where x is a variable and the y variable is always -3. X is defined by the parameters that it lives between -4 and 4. It doesn't include -4, but it does include +4. So we're going to first look at the y values. So y is -3. That's down here. Y is -3, but then x is between -4 and +4. 1, 2, 3, 4, and 1, 2, 3, 4, right there. It does not include -4, so we're going to put a circle right here. It does include +4. That's going to be a closed circle. Now, between these points really is a number line. This is our x number line from -4 to +4, but it lives where y is equal to -3 on the y-axis. So it's the same as we had before graphing our set builder or interval notation on a number line. We're just doing it in 2 dimensions, where we figure out where where it lives on the y-axis, and then we go from -4 to 4. A little bit different. Another point, same process, is we have x and y again as our point, such that we're given parameters. X is greater than 0, but then y is less than 4. So we no longer have a fixed value for one of our coordinate pairs, the -3. We now have variables for, or variation in each one of our variables for our xy coordinate pair. For the x, it is greater than 0, which means that we're looking at all of those numbers off to the right, positive side, and y is less than 4. So we find y on the axis, shadows in the way, and we're going below that point, or below that line. Now, in this case, we have to be careful. We don't have a line where we can do a set point where it's included with a closed circle or not included with an open circle. We're going to have to do solid or dashed lines. Since these are both strictly greater than or strictly less than, we have to use dashed lines. There are no solid lines because it's not or equal to. So x is greater than 0. Well, that's this line right here. Let me make that a little thicker next to the y-axis. My dashed line at x equals 0, where this is x is greater than 0. So we're looking at that side of the line. Those are all the x values that are greater than 0. But we have y is less than 4. Well, y is equal to 4 right here. Again, we're going to use dashed lines. This is the line y is equal to 4. We're looking at all the values of y that are less than 4. So we're below this line. This is a combination of the x's and y's. We're looking at all the points where it satisfies both the x's and the y's. So these are all coordinates, x, y, where x is greater than 0 and y is less than 4. So we are going to shade in this entire region. And of course it continues on. It doesn't just stop where the graph is. We're not going to stop at 10. We're not going to stop at 5. It just goes on infinitely in both directions. But it doesn't go above this y is less than 4 line, and it doesn't go to the left of the y is greater than 0 line. It is in this region. All the points that are described by x and y with these parameters are living in this field. We can reverse this process in graphing or describing a relation using roster or set builder method. Now, spoiler, we're not going to use the roster method on these. These are both going to require the set builder. And they are both sets of points, an x and a y. In this case, we have an x, which is always -2. And we have a y that varies. The y ranges from 3 to -4, or rather from -4 up to 3. It includes the -4 because of the closed circle. It does not include the 3 because of the open circle. So we're going to put y is between these two numbers. It's between -4 and 3. This is our y value. This indicates that x is always -2, but y changes. And this is how y is changing. Now, y is less than 3, but it's greater than or equal to -4. So we need to have our or equals sign for our inequality. Over on number 9, this one's a little more interesting. It's shaded like the one we saw on the other page. This is still in set builder notation, a set of points x and y. This time we don't have one of them set. They both float. So we have to, they both float in a set region, and so we have to give some definition or some boundaries to that region. X is going to be between two numbers, and y is going to be between two numbers. What is x between? Well, x is between -4 and 5. -4 and 5. And they're all dashed lines, so they're all going to be strict inequalities. There are going to be no or equals inequalities here. Y is between -3 and +2. So we're going to place y between -3, +2. Less than, less than. Now, what would happen if two of these lines were solid? Let's make that a solid line and that a solid line. Then we would have to include these lines. So the -3, y is greater than -3 or equal to -3 because it's filled in, and x is less than or equal to 5. So we would put an or equals bar under that inequality for x is less than or equal to 5 to satisfy the new change to this particular problem.